Okay guys, how about we do a little mini lesson on linear programming. So I have a problem here that I want to solve that involves a situation with a doctor and different constraints. Okay, so I want to break this problem apart and try to solve it. Okay, so with linear programming you always want to start with your objective. Okay, so my objective in this problem, if I look at the last two sentences, is to maximize income. Okay, maximize income. Alright, I'll even highlight it here. Okay, how many routine office visits and full physicals should the doctor schedule to maximize her income for the day, and what is the maximum income? Okay, so let's start out by defining two variables, an x and a y. Okay, in this question, I'm going to let x be office visits. And I'm going to let y be physicals. Okay? Now, let's go with our objective function now. What do we want to let that objective function be equal to? Okay? Well, let's see here. My objective, as I've already mentioned, is to maximize income. So our objective function should be a function that tells me about income. So I'm going to say I is equal to, now, where do I find the income? Okay, well, it's in the problem somewhere, right? Okay, let's find it and highlight it. Okay, a routine office visit costs $60. Office visit, $60. A full physical costs $100. Okay, so there's my cost. Okay, so that's going to deal with my income. Okay, so it's $60 for an office visit, so that would be $60 per X, plus $100 for a full physical, so that would be 100Y. So there's my objective function. Okay. Now the next thing I want to do is find my constraints. Okay. What are the other things in the problem that I have to take into account? Okay. So let's come up with a list of constraints here. First of all, we aren't going to have negative office visits or physicals, right? So we're going to say that both x is greater than or equal to 0 and y is greater than or equal to 0. Okay? Now, we should have a time constraint. Okay? So for our time constraint, let's see what we should have here. Okay? All right, let me get my highlighter out here. Okay? For time, it says we're dealing with 15 minutes for office visits and 45 minutes for full physicals. And it says the doctor has 9 available hours. 9 available hours. Okay? So that must have something to do with a constraint. Okay? So 15 minutes for an office visit, that would be 15x, plus 45 minutes for a full physical, which would be 45y. Now you have 9 available hours. Now that's a problem, you see, because our units don't match up. So let's convert 9 hours into minutes. So 9 hours times 60 minutes per hour would be 540 minutes. So the combination of office visits and physicals must be less than or equal to 540 minutes. Okay? Alright, now our last constraint on this one is going to deal with the fact that the doctor cannot do more than 10 physicals per day. Okay, the doctor cannot do more than 10 physicals per day. Okay, so if he can't do more than 10 physicals per day, that's going to be a constraint. Now that only deals with y. So y is going to be less than or equal to 10. Okay? So, we now have our list of constraints. Okay? So we have an objective function, and we have our list of constraints here, okay? So, once you have that set up, you're more than halfway done here. Now we're just going to go to a graph, okay? So let's move on to slide 2. Okay, on slide 2, I have a first quadrant graph. That's because of my first two constraints. Okay, x and y both have to be greater than or equal to 0. Okay. Now let's deal with the third constraint. Okay, 15x plus 45y is less than or equal to 540. Okay, all right, let me rewrite that over here. Okay, so we're dealing with 15x plus 45y less than or equal to 540. Okay, so I want to graph that. Okay, now the x-intercept for that. So the x-intercept for that using cover-up method is going to be 36. Okay, so I go down to the x-axis and I put a point at approximately 36. Okay, the y-intercept using cover-up method is going to be 12. So I put a point at 12. Okay. All right, so now I'm going to connect those 2 points with my line. And then I'm going to shade. Okay. Well, the origin's free, so it'd be 0 plus 0 is less than 540, and that is true. So I'm shading everything towards the origin. Okay. Now, our other constraint in this problem was a simple one. The other constraint was y is less than or equal to 10. Okay, well, y is less than or equal to 10 is a horizontal line. Okay, so we're going to draw ourselves a horizontal line, okay, that goes through 10. Okay, so a horizontal line that goes through 10 is going to look like that. Okay, and if it's less than 10, we're shading everything below that. Okay, so everything below that, that's also shared with the red. Okay. All right, so we get ourselves a nice bounded region. I'm going to outline the boundaries for you. We have a boundary of the x-axis and the y-axis, and then we hug the green line and then the red line, right? Okay, so we end up with this nice bounded region, okay? And it has 4 corner points. Okay, let's see exactly what those corner points are. We have the corner point 0, 0. Okay, we have the corner point down here of 36, 0. Okay, we have the upper left corner point, which is the point 0, 10. And then we have the corner point that's the intersection of the red line and the green line. Now, I know that the y value must be 10 because of the green line. And if I plug that into my red equation, if y is 10, I will find out that x must be 6. So those are my 4 corner points. Okay. So once you have those 4 corner points, now we're simply going to go to our objective function, which deals with income, and we're going to find out the income at each one of these 4 corner points. Okay. All right, so using the objective function, which, just to remind you, income was 60x plus 100y. The income at 0, 0 would be 0. Of course, I wouldn't have any income if I didn't take any appointments. The income at 36, 0 is 2160. The income at 610 is 1360. And the income at 0, 10 is 1000. Okay? So the question was, what combination of appointments should the doctor take to maximize income? Okay, so it's looking to me like the maximum is occurring at the point 36.0, okay, with an income of 2160. Okay, so X, if you remember, was office visits, and Y was physicals. Okay, so the actual answer here, we would want to say we maximize income with 36 office visits and 0 physicals. And the max is $2,160. Okay, so that would be our complete answer to this question. Again, this has been linear programming.